Hello everyone and welcome to a special episode of Last Minute FPL. This is the AI team walkthrough. Over the last few weeks, I was getting a lot of questions about how the AI team works, how it projects points, how it picks the teams, how it makes transfers. So I thought I'd do a live demo of how I actually run the AI team, how it generates projections, what data it uses. So I think this should answer a lot of the questions that people have, and I thought this was an interesting opportunity to document the model itself and how I run it each week. So we'll get started. Basically, I start with a data scraper, which at the end of each week, it looks at the previous game week's matches and it basically pulls all the data related to the team and the players. So the first thing that I do is I scrape this data from Opta Stats in the Fantasy Football Scout member area. So for example, game week 20 is the week that just passed. So we have 10 game weeks, and in Fantasy Football Scout, each match has detailed statistics. So for example, let's look at Wolves versus Forest. So if you open Wolves versus Forest, you have the XG data, you have when the game happened, and you have some team stats ranging from fantasy stats to expected stats, goal threat, which has the number of shots, how many shots were on target, and so on. And then you also have the player stats. For every player, you have their FPL cost, how many minutes they played, and then you have a range of tables for every player where, for example, if you look at expected stats for every player, you'll be able to see their expected goal involvement. So if I just sort it by this, you'll see that, for example, Strand Larsen and Avani, both of them had over 1 XGI in the game. So these are the source tables from which I pull the data. So I have a Python notebook that is dedicated to the data scraping part, which is this notebook. I use Beautiful Soup and Pandas to scrape the data. And basically I create a session where I log into my Fantasy Football Scout account. I've removed the username and password here for obvious reasons. But let's just run through one game week's data to see how this looks. So the previous game week was they have the game week IDs in Fantasy Football Scout for every game. So for example, the Wolves versus Nottingham Forest game week ID is 2444669. So that's what I do first. The last game week's matches were ranging from 2444660 to 2444669. And first I basically pull the team stats, which basically is what's the match ID, what is the date the game happened, which is the team, how many goals did they score, what was their XG in that game, how many goals did they concede, and what was the XG conceded of that game. And these correspond to certain column numbers in the Fantasy Football Scout page. So those are the column numbers that I basically pull. And I'm basically making an Ajax request that will then read the table, which is stored using a Beautiful Soup, which is the Python library. It scrapes this data and stores it in a text file. So yeah, that's what this code does. So let me just run this. So this is the first thing that I do. So it's iterating through each game. 2444660 is the first game, and then 6-1 and so on. And at the end of this, what I actually end up getting is the team stats itself. So let me pull up how the team stats actually look in the CSV file. So here you will see that I have scraped data from all matches from the 2017-18 season onwards. So for every game, you have the date, which team, how many goals they scored, the XG, goals conceded, and XG conceded. So at the end of every game week, when I run this, it appends the latest game week's team stats to this file. So let's see if this finished running. So the team stats finished running. And then I repeat the same for player stats. So player stats is a little more complicated. There are 5 different player stats tables that I pull from. The first is expected data, which is the XG, XGA, and which position the player plays, what's the nickname of the player, and that's it. It's basically expected assists and expected goals. Then we have the fantasy stats. So here, apart from the player details, I also pull how many minutes they played, how many goals they scored, assists they got, clean sheets, goals conceded, own goals, yellow cards, red cards, how many bonus points they got, and total FPL points. This is basically what you would typically see on the FPL site as well. So this is like my fantasy stats table. Then we have the bonus stats. This is just one data point for each player, which is the BPS itself, not the bonus points, but the baseline BPS that they score. Then for keepers, I have a separate table where I keep track of the number of saves they made and the number of penalty saves they made as well. And then finally, I have a penalty miss table, which keeps track of whether a player missed a penalty or not in that game week. So let me go ahead and run this as well, and then I'll show you how this table also looks in the CSV files. This code is doing pretty much the same thing. It's creating text files once it runs through every match. So again, it's running through all the games of the previous game week and running through all the players and scraping their data. And then I'm appending the data to the master files. And now let me quickly show you how this data looks. So let's start with the keeping data. So for every game starting from the 2017-18 season, stored by match ID, which player, their nickname, full name, position, team, number of saves made in that game, number of penalty saves made in that game. So there's a lot of entries here, but this is the file that the code that is running will append to. So this is the keeping data. And similarly for fantasy data, for every game, every player, you have the cost, minutes played, goals scored, assists, clean sheets, goals conceded, own goals, yellow cards, red cards, bonus, and their actual FPL points. So all these data files that I'm creating will actually be used to train the model as well as to predict the points of future players based on their current stats. And then this is the expected data. So again, for every player in every game, what was their expected assists and expected goals. And then this is the bonus BPS data. This is needed to calculate how many FPL points they got in the past. So again, for every player, we have this piece of information. And then finally, penalty miss. This is a very sparse table because most players typically don't miss penalties in a single game week, but I needed to keep a separate table for this because I couldn't find a single data source that had penalty miss in combination with the FPL stats. So now this has finished running. So let me just refresh these files and check if our latest games have been stored. So yeah, Nottingham Forest versus Wolves was the last game. So there you see it, 5 saves made by Sells this week. Again, Newcastle versus Tottenham, and Brandon Austin was the keeper this week. So this is my verification to see if the data is actually appended or not. Similarly, I repeat it for the other files. Again, Wolves versus Forest was the last game, so we're good here. Expected data here too, Wolves versus Forest. Bonus, again, Wolves versus Forest is here, and then penalty miss. So yeah, Wolves versus Forest is here. So that's all with the scraping part of the data scraping part of the model. Once this is done, I move on to the data transformer, where basically now we have all the raw data, but we need to transform this data into a state that the model can actually use it. And as I go through this piece of code, I'll explain some of the nuances of this data transformation. So the first thing that I'm doing is I'm setting a recent window and a long-term window. So this can be thought of as the form and the class period of a player. So 4 game weeks is what I'm considering as form, and 15 game weeks is what I'm considering as class. So form, and this 15 game weeks is before the previous 4 game weeks. So effectively, we're looking at the previous 19 game weeks of a player's data to predict their future performance. And here I'm just transforming the date into a form that Python can understand in pandas. And then this is the team stats file that we had created earlier, which is this file. And I am converting it into a pandas data frame so that I can use it in Python. And then here I'm just checking if it's lying within a particular date range. And then this is an interesting part where we usually have some promoted teams who don't have any Premier League history or data that we can use. So the first time a new team shows up in this data set, and by a new team I mean from 2017, because that is when we actually started storing this data, we need to have some way of assigning some historic data to these teams. So the approach I took is to identify a lookalike team. A lookalike team is basically a team that is already in the Premier League, and we think that this new team will likely perform to that level of that older team. This is just a substitute while the new team effectively creates some data of its own. So in the first 19 game weeks of a season, we don't have enough data of a new team to be able to make accurate predictions. So this is like a workaround. It's not going to be accurate, but this is the solution that I found. So what this does is, for example, the first time that Wolves shows up, I basically chose Stoke City as their lookalike team based on their performance in the championship in the seasons before the seasons where they got promoted. And so when Wolves basically plays a game week 1 fixture, they would basically be assigned the same data that Stoke City had at that particular point in time. And as each week goes past in time, Wolves would have more of their own data and less of Stoke City's data. Similarly, Fulham, I chose Swansea. Cardiff, I chose West Brom. And like more recently, Luton, I chose Watford, and Ipswich, I chose Burnley. Some of these are like based on my personal estimations of what I think the team will do. Again, it's not going to be exactly accurate or the best thing to do, but it's a workaround while the new team builds some data. I've not found it to affect the model too much, because typically anyway we wouldn't pick too many players from new teams, especially promoted teams. But this is some way of ensuring that these promoted teams and players have some data at least. So that's what I'm doing here. And you'll see that there is this column at the end of our team stats, which is called data point, which I've set to true if it's an actual data point, and it would be set to false if it's actually a lookalike team. And then at the end of it, I create a team fixtures dictionary where for every team and every date, you actually have form and class data. So let's say Wolves on 14th May 2018, we're looking at 4 weeks as the short term, and they have 0 weeks as long term because they don't exist in the database before that. And in the 4 weeks of short term, this is their XG, this is their XG conceded, this is their goals conceded, how many clean sheets, and how far back we're looking. So this function that I've created called get team features will tell us both short-term and long-term data in this format. So that's the team data. And then I do the same thing for player data. For player data, like we saw, there are 5 different tables: bonus, expected, fantasy, penalty miss, and keeping stats. But we need to combine all of them into a single table. So that's what I'm doing here. And at the end of it, we have a single table that has 81,200 rows, where for every row basically corresponds to a single player in a single match and their entire data for that match. and you'll see that saves and penalty saves will only apply to goalkeepers. But there is a whole host of columns, like so for every player you have their nickname, full name, position, which team they play for, what was their cost in FPL, how many minutes they played in that game, how many goals they scored, assists, clean sheets, goals conceded, lot of data points. And then we're just looking at the last few data points to make sure that we have the latest game, which is again Wolves versus Forest. And then what we do is we calculate the actual FPL points that the player scored based on their BPS and assign that as a column towards the end. And this is just for the label. Basically, to be able to train our model, we need to know how many FPL points they actually scored in that game. And then here I'm just checking for players who've got negative points. Just as a sense check to make sure that no one has too high a negative points scored. So -1 is a reasonable FPL score. So for example, if I saw something like -10 or -15 here, then I'd know that probably I made some mistake while scraping the data, because sometimes the order of columns in the source table changes from where I'm pulling the data, and this is my way of ensuring that doesn't happen. And then similarly, I'm just querying one single match to see if the data is showing up, and one single player, in this case Solanke, just to see if the latest data is there. And then I'm repeating what I did for teams, for players. So what you'll see is, for example, Dominic Solanke, if I look at 1st October 2024, what was his stats in the last 4 weeks for short term and 15 weeks for long term, and I get this function basically gives me all the data for that player in this range of game weeks. Similarly, for Alexis Sanchez, if I look at 1st January 2021 and I say give me the data for the previous 20 game weeks, this is the minutes he played, goals, assists, XG, and everything, and so on. So this is the function that I can plug and play to identify data for any player given a particular date range. And then here, what I'm doing is I now have a list of 81,000 data points, but I only care about last game week's games. So what I do is I look at what the the previous game week start date was. In this case, it's 4th January. So any games that happened before 4th January, I don't care about. I don't want to pull that data because I already have it. So what I'm saying is, if this game happened before 4th January, I don't need to do anything. And if it happened after 4th January, I'm going to add it to my final list of data points. And this is where I create a final data set, which is a file that basically has all the data points of all the players starting from 2017 in a single file. So far we've seen all the data points in different files, but we want it to be in a single file, which is this file, where this includes keepers, defenders, midfielders, forwards, everyone, and all the data points. So this has a lot more columns than what we saw up till now, but it's basically a combination of all the tables. And what this also does is it looks at the previous 4 game weeks for the form data and the 15 game weeks before that for the class data, and it creates data points for that. So for example, there's a column called recent XG, which is the XG that the player has in the previous 4 game weeks. Recent XA is expected assists in the last 4 game weeks. So anything with a recent prefix is the data for the last 4 game weeks. So you have goals, assists, clean sheets, and so on. And then once the set of columns titled recent end, we have a set of columns that start with the prefix long, which corresponds to the data points of the players in the 15 game weeks before the previous 4. So if this is game week 20, recent data corresponds to game week 16 to 19, and long data corresponds to game weeks 1 to 15. And then again, for this range of 15 game weeks, we again have the same set of data points. And once this long data points end, these are the data points for the players. Now we have the same thing for teams. So every row corresponds to a player, but that player also plays for a team, and the team stats are also relevant. So we look at the team's recent stats and the team's long stats, which is basically the team's form and the team's class. And again, we have goals conceded, expected goals conceded, and clean sheets. And then the same thing for the team long data. And then finally, the fourth and final type of data points that we store for a single player is what was their opponent's quality. So we started with the player stats, then we had the team stats, and we also we had the players form, players class, teams form, teams class, and now we're going to have the opponent's form and opponent's class. So you have opponent recent data, and then you have opponent's long data. And then finally, at the end of this, at the end of it all, we're saying these are the FPL points that the player scored. So the hypothesis here is that this column, FPL points, is a function of all the other columns that we saw here. Some columns are going to be more important than the others. Let's say that the expected goals of a player in recent, the expected goals form of a player and expected goals class of a player may be more relevant than, let's say, the expected goals of your opponent when it comes to a forward. So we let the model decide which columns are important and by how much. But basically, this is the entire master data set that we've put together. So let's go back to the data transformer. At this point, we've created the data set. We're just verifying that no player has a negative expected goals, because that would mean something went wrong. Then again, just like for the teams, we had created a lookalike team for every unknown team. We're also doing that for players. So if there's a new player to the Premier League or a new transfer who doesn't have historic data, we have what is called a lookalike source, where we look at players who are priced similar and playing for the same team and how they did in the past, and we assign their history to this new player's history. This is again a workaround while the player plays in the Premier League and gets some actual data in the Premier League. Again, this may not be the best approach, but this is the workaround that I've gone with. And at this point, I can also show you an example of how that looks. So let me just give you an example. So if you have lookalike source, when Saliba came into the Arsenal team in August 2022, the lookalike player that was chosen for him was Ben White. Or when Ibrahim Konate came into Liverpool in August 2022, the lookalike player was Joel Matip. Tsimikas, Andy Robertson, Luis Diaz, Diego Jota. You get the gist. Basically, while these players build up some data of their own, we assign to them the closest, or what we think is the closest player who potentially played in the same position and could have got similar results. Once this is done, we then need to look at the next 4 game weeks of FPL and start predicting the points that the players will get for those 4 game weeks. So we use this Python library called FPL Pandas, which is a very useful Python library that helps us integrate FPL data with Python. So this basically is getting us the fixtures of the next 4 game weeks. Our next game week is game week 21. So we're going to look at game week 21, 22, 23, and 24. And that's 40 games. And for these 40 games, these are the 40 games. And for these 40 games, we're going to build a data set that is going to effectively be very similar to this, where you have all the players who are going to play in the games. You also know all their recent data, you know their long data, you know their opponent's long data, you know their opponent's recent data, you know their team's recent and long data. The only thing that we don't know is the FPL points, because that's something that's going to happen in the future. But given the model that we will train, which will learn from this huge set of 58,000 odd data points, the model will then be able to predict what the FPL points for these next 4 game weeks will be based on the same logic. And so let's create that data set for the model to predict it. So let me just run through this. This is just a player correction because sometimes the names of the players slightly differ in older versions of FPL and newer versions of FPL. So we're just making sure that all the or if they have some accents on their letters, we're trying to make sure that the same players are referred to each time. And then we create this test data set, which I will show you how that looks once it finishes running. And that test data set is what the ML model will have to predict the FPL points for. So let's just let it finish. Okay, so this is done, and I will show you how that looks. Yeah. So this is the final test data set for the next 4 game weeks. So these are games that haven't happened yet. So if you look at the date, it's 2025 mid-January onwards. Let's just take an example. Let's take Erling Haaland. You'll notice that there are some players in this who have already left the league, but that's because their names are still in the FPL database, but we'll ignore them later when we look at their expected minutes. But let's take a look at Haaland. So Haaland is playing Brentford next. His cost is 14.8 million. In the last 4 game weeks, he's had an XG of 2.75, an XA of 0.29. He scored 3 goals in the last 4 games, no assists, 1 clean sheet, although that's probably not relevant for a forward. No yellow cards, no red cards, saves are not relevant, 5 bonus points, 23 points in the last 4 game weeks. And then we look at the 15 game weeks before that. Still a very healthy 13 expected goals in the previous 15 game weeks. Not much of an expected assist, 12 goals, 1 assist, and then we have some other long-term data, 93 points in those 15 game weeks, averaging just over 6 points a game. Then we have the team data. So City have scored 8 goals in the last 4 games, conceded 4, 6 expected goals in 4 games. And then let's skip ahead a bit. This is their opponent, Brentford. How many goals have Brentford scored? How many goals have Brentford conceded? What was their XGC like? And then long term, how did Brentford do? How many goals have they scored? How many goals have they conceded? For Haaland, probably Brentford's defensive stats will be what are most relevant, but you get the idea. So this is one data point. Similarly, you'll have 3 other entries for Haaland, depending on the other 3 fixtures that City have in the next 4 game weeks. And at the end of this, we basically have 1 entry for every single player and fixture in the next 4 game weeks. So that basically brings us to the end of the data transformer part. And then we'll move on to the points projector. This is where the crux of the AI model actually is. So what happens here is we first read the data that we've created in this final data set, which is the one where it's the historical data, where we actually have the FPL points for all the data starting from 2017 up until now. Sorry, this final data set is all the data, and final test data set is the one which doesn't have the FPL points. So all data basically has more than 50,000 entries. Test data only has the 1,000 odd entries for the next 4 game weeks. And once we run this, we have some edge cases that we need to tackle, like 2 players having the same name, and we rename them. And then this is where we decide the features. So there was a lot of experimentation that I did in previous seasons, where I looked at which columns or which features of the data actually had the most correlation to FPL points. So for goalkeepers, for example, the features that had the most significant correlation to points was the team's recent expected goals conceded, the team's long-term expected goals conceded, the opponent's recent expected goals, and the opponent's long-term goals. So this broadly makes sense because for a goalkeeper, your own team's defensive stats and the opponent team's attacking stats are likely to be the ones that are most significant. So at this point, we're telling the model to use these 4 columns for day as the features to train on. And the last column, FPL points, is the label that it's trying to predict. Similarly, for defenders, this is the entire master list of features, out of which a few features were selected. This is still a lot of features, and probably some more feature engineering can be done. But in the current state of the model, for defenders, the individual players' attacking points, attacking stats, so expected assists, long-term expected goals, long-term expected assists, how many actual assists, recent points, long-term points, team's defensive stats, so these are the expected goals conceded, and also the team's attacking stats, because defenders get points for assists and goals as well. So there is a bunch of team attacking and defensive stats, and also the opponent's attacking and defensive stats. So if you're playing a team that is really good in attack, you'd expect your defender to score less points. And if your opponent's team has a bad defense, your defender could probably get attacking returns. And also finally, the opponent's clean sheets. So if they kept a lot of clean sheets, maybe your defender won't get attacking points. Excuse me. So these are the defensive features that are selected. And at the end of it, again, we create a table where for every entry, every defender entry, you have all these data points, and at the end you have FPL points. So the model will try to create a function of all these data points that will actually give you the FPL points. Then we have the midfielders. So for midfielders, again, recent expected goals, expected assists, actual assists, recent points, recent clean sheets, long-term expected goals, a bunch of individual attacking data, but also your team's recent and long-term attacking data and your opponent's defensive data. This makes sense again because for defenders, your primary source of points are attacking returns. And then for forwards, it's very similar. The individual players' attacking stats, the team's attacking stats, and the opponent's defensive stats. So at the end of this, we've basically created our data tables for the model to use. And now we need to use some machine learning algorithms to actually be able to predict the FPL points. So at this stage, I basically experimented with various regression models that would predict the FPL points, and I looked at what the accuracy of these models were. And the model that I ended up landing on, and I tried using the same one for all of them just to maintain some consistency, was a combination of the linear regressor, the gradient boost, and the MLPR. So basically, this is a voting algorithm which takes some weightage of all these 3 regression models. This is a very basic model, but it has served me well, and keeping it simple actually makes it easier to understand instead of using something more complicated like a neural network where I'm not understanding why the model is predicting certain players as doing well or not. But there is room for improvement, and probably between the seasons, that's something I can work on. But let's take a look at what happens when we actually use this to predict some of the points. So like let's for example take Kulusevski playing for Spurs against Forest. It predicts that he's going to get 3.73 points. So what it's basically done is it's used its knowledge of the 50,000 plus data points in the historical data. It has looked at players' likelihood of scoring FPL points given all the other features. Then it looked at Kulusevski's current fixture for Spurs playing against Forest, looked at Kulusevski's form, his long-term class, Spurs current form, Spurs class, Forest form, Forest class, and it's landed on this number of 3.73. And then this was for the midfielders. So similarly, we do it for the forwards. So if you run for the forwards, you'll see that there are some players who are not in the league. You can ignore them because they're still in the FPL database. But let's take a look at Mateta against City, for example. Says that he'll get 3.84 points. We can then do the same thing for goalkeepers. We'll see that Alisson against Newcastle is expected to get 3.01 points. Let's do it for defenders, and we will see that let's take an example of someone who we know is playing. Ruben Dias is expected to get 4.2 points against Ipswich. So now we have a lot of data points. We need to put them together in a clear and easy form to understand. So what we'll do is we will basically we created tables that are a little better to understand, but probably still a little difficult to visualize. So let me just do some transformations so that visually also we can take a look at it and see if it makes sense. So this is just some code that is transforming this data, and we are predicting game week 21 to 24. What we're doing is we're also calculating a total expected value. So what this means is that my confidence in predicting game week 24 is a lot lesser than my confidence of predicting game week 21. So game week 24, for example, I'm giving it a lower weightage when I make a decision now, because something could happen between now and then. Maybe injuries, maybe some loss of form, maybe data will change. Whereas game week 21 is right here, right now, so I have more confidence. So I'm multiplying the later game weeks with a factor of 0.85, which is just a number that I chose as a DK. And at the end of it, we get a single table, which is sorted by the expected value, I'm guessing. Should have sorted it by expected value. If not, maybe it's by total points. But what it's saying is in the next 4 game weeks, Salah is expected to score 34 points at a total expected value of 27.2. Lesser confidence in later game weeks, which is why the EV is lower than the total points. And then next is Cole Palmer, expected points of 28.66. Alexander Isak is third, 24. Saka, 21.6. But of course, he's injured, so we'll ignore him based on his expected minutes. But if he were playing, this is the expected points. And then Gordon, pretty highly rated. Haaland coming in 5th. Then Mbuemo, very high in the table still. Bruno, Cunha, Wissa, and so on. So not only do we have an exact expected points for every game week, we also have a total expected points and expected value for the next 4 game weeks. And this is where I will write it into a HTML file that we could look at if we want. But what I actually do at the end of this is I create a single file where I write all these players into, and then I only look at the players who I think will start. So let's actually do that. So this is the end of the points projector, and let me now go into the team optimizer. This is the final step. So team optimizer is the final step, and this is where we effectively want to identify what is the transfer to make. So what I do at this point is if this was a game week 1 or if this was a wildcard team, I actually have an optimizer where you can give a team value and set a formation and basically ask the model itself to pick a team. So for example, here I've given the formation as 3-4-3. If this were game week 1, it would run the model and tell you what the best team to form is. So this is what it thinks the best team is. If the formation was 3-4-3, it wants you to play Trent, Dan Burn, Lewis Hall, Wissa, Jimenez, Isak, Pope, Palmer, Gordon, Salah and Mbeumo. Of course, this team's not possible because I think I see 4 Newcastle players. But that if you add that constraint, you can fix that as well. Similarly, a different formation, 4-4-2. At the end of every one of these teams, it has a total projected points for the next 4 game weeks, excluding the captaincy points. So you would have to double that. So this is the optimizer that I would use if this was the game week 1 team or a wildcard team where you have unlimited transfers to make. But because this is not a game week 1 or a wildcard team, what I actually end up doing is I basically write all these values into HTML pages. Usually I only look at the players who have expected points over 60 minutes from FPL review, which is what I use as a source of truth. But right now, just to save some time, I've written all the players into these files. So it also shows, let me just move this around a bit so that you can see the whole screen that I'm seeing. Yeah, so this is the goalkeepers page. I hope this is visible, but this includes goalkeepers who we know are not going to play, like Kelleher, for example. Yeah, like ideally before this page is created, I would filter out the players who aren't gonna play. Let's look at defenders. Let me just make it a little bigger, and then midfielders, and then finally forwards. Right. Got it. So yeah, I mean, there are different visualizations that I have created for this purpose. For example, I have one where the projections are a bit more clear and only showing the players who are actually going to play. This is from a few weeks ago. This is from game week 16. I currently don't have the time to create this slightly better looking visualization, so I'm sticking to my simple one where it's just a simple HTML and it has all the players. But let's quickly walk through how I actually make the decision of what transfers to make. So let's quickly go to fpl.team, and this is a really nice website to this is my team. Let me just fix this again. Let me just pull the FPL ID of the AI team. And so this is the current state of the AI team. It has 1 free transfer, 1.8 million in the bank. Timber was suspended last week, but let's say he comes in to play this week. Rogers was also suspended last week, so let's just set the current starting team once, and then we'll look at how these players are expected to do in the next 4 game weeks and the next 1 game week, and make a decision on the transfer. So ideally, again, at this stage, I would build an optimizer, but at least we have exact numerical, mathematical projections of what the expected points of these players are. So we should still be able to make informed and mathematical decision and not human-based decision. So let's look at the defense to start with. I think in defense there is a clear potential to make a move, I would say. So for example, Trent is clearly the highest scoring defender in the next 4 game weeks with 14.08 as the EV, but second is Hall at 12.68. And if you actually look for Saliba, he's all the way down at 10.49. So if you look at our team here, we see that Hall is actually projected to score more than 2 points, 2 expected value more than Saliba starting this week. So that is one potential transfer that we have. The second potential transfer, let's look at midfields. And since it's just one free transfer, I would only take a hit if the expected value exceeds that player out by more than 4 points in the next 4 game weeks. And also the very immediate game week should also be better for the player coming in. So let's see, Hall is 4.21. Let's look at Saliba, 3.09. So definitely Hall is expected to get around 1.1 points more this game week itself. And in the total EV, he's expected to get more than 2. So Saliba to Hall is a candidate move. And in midfield, let's look at the midfield. Our current midfield is Salah, Palmer, Gordon and Eze. And if you look at who the best midfielders are, you have Salah, Palmer. Saka's injured, so we ignore him. Gordon, we already have him. Above Eze, we only have Mbumo and Bruno. So potential transfers would be Eze to Mbumo, but if you look at the amount gained, it's 0.8 over or maybe even 0.9 over the next 4 game weeks, and in this game week it's just 0.12. For Bruno, we do gain a lot more in this immediate game week, but overall in the next 4 it's just 0.6. So this is less of an optimal move compared to Saliba to Hall. Remember, I'm not looking at blank game weeks, like the fact that Newcastle could blank in game week 29. Chip strategy and planning is something I haven't modeled yet. I still do that manually and make the assumption that this is the chip strategy that the AI team is going to use. Then let's look at forwards. The current forwards that we have are Wood, Pedro and Isak. Pedro's injury news is pending, but for now let's assume that he's playing. At Pedro's price point, if we were to get rid of him, we would have 7.5 million. So let's just once quickly take a look at who are the forwards below 7.5 million to start with. Is there anyone above him? Wissa maybe, but again, the gain is lesser than what Saliba's gain was. So Saliba to Hall, we were gaining more than 2 points, and the only 2 players above that are Isak and Haaland in terms of the delta. So I don't think moving Pedro out makes sense unless he's injured, in which case I'll revisit this. And the other 2 forwards that we have in the team are Wood and Isak. Isak is anyway expected to be the highest scoring forward, so we won't make any changes there. Wood is someone who is relatively a little lower in this table. And his next game week doesn't look that great either. I guess it's because it's City. Is he playing? No, Liverpool, right? So 13.52 plus another 2 points is around 15.52. So again, Haaland and Isak are the only ones who will gain us more points than a Saliba to Hall move. But one thing we should check is, let's also quickly check keepers. I mean, it's usually an academic thing because keepers aren't usually separated by much. But Sells is our keeper. He's expected to get 11 points. Allison is 11 point something. So the entire keepers they're not usually separated by too many points. So let's come back to the team and let's see if there is any argument to be made for benching anyone. Let's look at Rogers and see how many points he's expected to get. Rogers is expected 4.36 points this week, which is more than Wood. So we would play Rogers over Wood. Let's just make sure all our other attackers are getting more points than Wood. Eze 4.87, Wood was 3 point something. Pedro's also 4.74, which is higher. Salah, Palmer, anyway, a lot higher. Gordon is also above 5. Who else? We already checked Rogers. Isak is 6.1, so that's also higher. Let's look at Mykolenko. Mykolenko is only 2.45, and if we were to get Haaland, he's over 4. So yeah, I think at this current point, my transfer, if this was deadline time, would be to move Saliba on for Lewis Hall. And for captaincy, let's look at next week's individual forecast. Salah is expected over 8 points this week, and no one else is even in the vicinity, which is a bit surprising for me because Salah is playing Forest away. But I listened to the model, and so far it's been working extremely well. As you can see on the bottom left, it's currently ranked an amazing 2.1k out of 11 million managers overall. And so yeah, I think that's basically what I do to run the AI model. I hope this was informative, and if you stuck till now, do like this video, and feel free to drop some comments, and I'll try to answer any questions that you may have.